Hey, all, my name is Jonathan. I'm a product manager here at NI, and today we're going to be taking a look at how to use your PXI SMUs and getting that full out-of-the-box experience, getting your first measurements done using Instrument Studio. Today, in our chassis, we have our PXI 4145. This is a 4-channel medium-density SMU, and we have it hooked up to a DC to DC converter. Let's go ahead and hop into Instrument Studio and take a look at what we can do right away and get this device fully powered up. So you have the choice to do an auto create that's going to populate Instrument Studio with whatever it thinks is best suited, put the instruments within your chassis. However, since we're only using the 4145, we're going to go ahead and do a manual layout and select that as our only large panel. For our own viewing pleasure, we are going to turn off auto scaling because we know that we're working within a 5-volt boundary and we don't want the graph to jump around on us. We'll go ahead and set our maximum key a little bit higher than that. And we'll leave the auto scaling on our current as is. So we've turned on the channel 0 of our SMU, and we are supplying a true 5 volts into the dot at about 13 to 14 milliamps of current. However, if we want to verify that we are in fact getting 3.3 volts on the output side, well, we could turn on channel 1, set that to okay, turn on our output, hit run at the top, and now you can see that we are in fact getting 3.3 volts on the output side of the DUT back into our SMU, while we're still sourcing 5 volts at about 7 milliamps of current. However, if you wanted to see what the SMU looks like as an electronic load, we can actually go ahead and configure our current on the output channel. We'll set that to negative 100 milliamps. And you'll see that the input current on channel 0 has to adjust itself in order for us to get that 3.3 volts on the output. If we wanted to ensure that we are actually pushing that as best as we can, and we're getting the measurement as accurate as possible, we can change our sense lines to be remote on both of the input and the output. And that's just going to compensate for any lead drop across the channels themselves. So you'll see on the input, we are sourcing 5 volts, sourcing about 73 milliamps. And on the output, we are getting our true 3.3 volts while using the electronic load capabilities, syncing about negative 100 milliamps. So to conclude, we've used our SMU today to source power to our DUT and take that same power and sync it back into the SMU, and using our SMU as a DMM to capture those measurements. All within Instrument Studio, our tool for visualizing what we've done. Thanks for watching.